we go. So first step, in as far as when you're multiplying, notice that my left-hand side and my right-hand side, I've got two complex numbers and I'm multiplying those together, okay? So just like you would know, step one, we FOIL, right? First, remember what that represents? First, outside, inside, last. So first, I'm going to get an 8 outside, positive 20i inside, negative 6i, and then I have the last, I get negative 15i squared. Remember I told you today we're going to see that I squared business? That seemed pretty not bad, like you already know how to do that. Just may look a little weird with the complex. Alright, step 2. This is where you know, just to give you a little tidbit for your notes, that this is when we plug in, like we're going to substitute in that -1 of what I squared represents. So what is that going to do to that negative 15? Yeah, whatever coefficient sitting here, right, it's always going to change that sign. Okay? So if you ever want to just, if you get it, you're good type of a thing, then you know that's where we're going. So this piece is that happening. So that's where that positive 15 comes in. And just because I'm writing out the steps, which is why I did not combine those yet, because that's part of the steps, but I'm just writing everything out. CLT, combine like terms. Whenever I say CLT it, you know, combine like terms. So that gives me a positive 20 and a negative 6. That gives me a positive 14i and a positive 15. Do I have any other like terms? So I grabbed my i's. Yeah, the 8 and the 15 I also can combine, right? So these are also like terms. So I'm going to go ahead and combine those. And what does that give me? 8 and 15, that's a 23? Is that what that is? Yep. So positive 23. There you go. So always grab your i's. That gives you your imaginary combined term, and then look at those real numbers and see if you can combine those. All right, ready for 2? Does that look just like something similar that we did on example 1?
Yeah.
Yeah. So we're just going to do the exact same thing. So we're going to follow the steps. We're going to do our FOIL. We're going to plug in the -1 for our I squared. If we have that, which I'm sure we will, then we're going to CLT whatever we can CLT. Okay? So go ahead and FOIL. Let's see how you do that. Got to practice that. Remember to do the first terms, outside terms, inside terms, last.
What do you mean by first? Like start with 7 and 4?
Yep.
I'm kind of stupid. I really don't know. You should do this.
All right, so first I have 28. So 7 times 4. And then, Yep, and then outside I've got, what is that, negative 42? I. And then inside, negative 36. And then last, I get a positive 54I squared. Okay. So this piece, that's a positive 54, so that I squared being a negative 1 is going to change your positive 54 to negative 54. Okay? So I know that will be a negative 54. And then I've got my I's here. Got a lot of things happening. I wrote really big, so hopefully you'll have room to simplify it all out. That gives me, when I have two negatives, I know I'm adding them in the adding and subtracting world when they're the same sign. So I get a 78I. Okay.
So 28 minus 78 I minus 54.
Yeah, so now my I's are all good, right? So that's staying. So I've got the positive 28 and the negative 54. So they're different signs, so I know I'm subtracting them. I can't subtract 1 from 5. Is that an 8? Yeah, that's an 8. So I got a 6. So 26, negative 26, is that what you get?
Believe so.
Yeah. When I was subtracting and I borrowed from my 5, I made it a 3.
Wait, 26 or 29?
It's 26. Because when you make that 4 into a 14, 8 goes into 14 6 times.
But that's division, not subtraction. I thought we were doing subtraction there.
I did subtract. And I had to borrow. And I had to make my right here.
Yeah, no, I get that. I think I just misunderstood like the way that you said it, because you said 8 goes into 14 6 times. So I was like, what?
It does. Yeah, 8 goes into 14 because I made that 4 14, right? So that's a 6. And then I had 4 minus 2. That's not 2.
Okay. I think my brain is just turning off.
You are. You're malfunctioning this morning.
I am. I'm
Okay.
guilty.
All right.
This will be normal for me.
All right. What's different on how they give you the problem on number 3? Yeah, it's weird. So in other words, we just got to it's the same number, right? Same set, same complex number. They just combined them because it was the same on each. So that was just that squared. But you're still doing the same business, okay? All right, I'll give you a minute. All right, benchmark yourself. Make sure in blue that when you fold it, did you get the blue? Okay. And then this piece will turn into, that's positive 4 times a negative 1. So that would turn into a -4. And then I've got to combine my
Nice.
how'd you do?
I did pretty well by myself, except my brain keeps turning off, so I was thinking additions.
Yep.
For the sevens together.
All
so
right.
I wrote 14. So
What do you think, what's going on at the example 4?
Same thing as everything else, just
it's just
There's
the first
one
one
less.
isn't a complex.
Yeah, we're not doing the FOIL, right? We're
Yeah.
just distributing that 3i through,
Yeah.
okay? So they're just trying to mess with you. But yeah, we don't have to do the first, outside, inside, last type of thing. So just multiply the 3i through. And I'm not going to do every single one of these with you, so you can have some practice problems. But I am just getting you to focus on the ones that are different.
Okay. So there isn't a practice sheet to go with this?
It's at the end, those bottom ones.
Oh,
Mhm.
the your turn was?
Yeah, I mean, I do have a separate practice sheet for you.
7
But-
is interesting.
We'll see.
Okay.
We'll see if you need it.
Just with the answer we end up with.
Well, because I know that we didn't do a separate practice sheet yesterday.
Right. Yeah, that one had extra on there too.
Mm-hmm.
Okay. Hi Joey, what'd you get?
21i, or negative 21, yeah, 3i squared.
Okay, positive 3i squared.
Yes.
Okay, so what are we supposed to do from that?
You subtract 1 from 3i, to make it take out the I.
Right, so the I squared makes that positive 3 turn to a
Negative.
-3. Good. So now you've got this junk. This, but how do we need to fix that? Need to get it in our famous standard form, right, for complex numbers. So what do I need to do with that -3?
Negative 3.
Yeah, I need to flip flop them, right? So it's just -3 minus 21i. Very good. Good job. Okay. Not really worried about the conjugate stuff. I mean, we can talk about it, but okay, I'm gonna leave you to the couple that are on the front. So, is your notes going to the back? Okay, good. All right. I think you have like a blank there, a couple of blanks up there. Let's see. Yeah, well, I changed these notes, so mine's like kind of on the same page. But it should have like find the complex conjugate, but then you should have a blank right there. All right, so this is where we would talk about, well, what is a complex conjugate? This is when you have A plus BI, and then you have A minus BI. So whenever you have something like that, these two are complex conjugates of each other. So when you multiply them together, the imaginary parts Yep, they go to 0, right? They'll go away. They're going to be additive inverses of each other. And when you get finished writing that, look at example 7 that's on the front page. What do you see there? Are those complex conjugates?
Yep.
Yep, they sure are. So if we actually work that one, we would see where the imaginary parts, and you'll see that when you're practicing. Okay? So like example 7 is definitely the example for that, just so you can see what's happening there. Okay? What would be the complex conjugate for A? 5 minus 6i. That 6i in the example is negative, right? So what is the opposite of that? We've got to make it positive. So 5 plus 6i would be the opposite of that. Remember, you're going to have one that's going to be a positive, one that's going to be a negative. So if they gave me the negative, I've got to have the matching one for it. That would be positive. Okay? So if I want that positive 7i to go away, what is its complex conjugate? Negative 7i. That's right.
So this is basically
That's all it
cleaning up
is.
and getting rid of the.
Yep. That's something you would apply, is division. That's the application part to this, which is the multiplying piece. So yeah, but we're not, it's just as long as you're exposed to it, you're fine.
Yeah, so C would be 2.
Yeah, so 2 minus 3i.
Okay.
Because they gave us the addition part, we need the subtraction part.
Alright.
Okay? Hi. How are you doing? Okay? Okay.
It's gonna get worse.
Last piece. This is not bad. It's just you got to think a little bit about what it is we're doing. Okay? Let me scooch this up for you. And then after this, I will turn you loose to the practice problems that are there at the bottom. Okay. You see the little... Hey, come on. French vanilla. Are you offering it to the kiddos?
Yes.
Yes. Do you guys want anything? I've got some takers.
Can you put the sugar free on here?
Yeah, sure.
And put the hot chocolate in the too.
Hot chocolate. Got it.
You want to hand it to me, please?
Miss Breeze.
Thank you.
You're welcome.
I think, yeah, they usually carry the tea there. I don't know if they've got hot chocolate or cider, or I think they have all that.
Yeah, it is.
Yeah. I'll see how you guys can drink that stuff. Man. All right, I'm gonna go ahead and continue since. So, anyway, all right. Do you see how this should be on your paper, right? Do you not? Do you have the little? No. Okay. Okay. Yeah, it's not on mine either. I had to actually put it on mine. So yeah, it wasn't on mine either. But like this first piece, I'll just write it here so you can see what it is because it is kind of hard to see. So what that says is that it's I to the 0 power equals 1. I don't know if you remember your 0 power rule. And then this one is just I to the first. Well, that just equals I. Okay. Then we learned, what does I squared equal? -1, right? So I to the 0 is 1. Well, then I is negative 1. And if I to the first is I, what do you think I to the third is going to be? Negative I. So you're going to have one that's representing a positive one that's representing a negative one, then you've got an I and you got a negative I.
So like
Okay.
evens are negative and odds are
Well, no odds because this is a negative I.
okay.
Okay. All right. There's ways, there's lots of different ways that we can go about, a lot of people like assign values and stuff to it, to when you're doing the division piece, but I just do it kind of simple. I don't put any craziness to it. All right, so we know that, so I kind of put it like in a circle, is that to go from here, this is 0, so 1, 2, then here my exponent is 3. Well, this would actually get me back to 0 if it was a 4, right? So to go all the way around to get back to the 1, where I of whatever power of 4 equals 1. So in other words, every full to go back to the starting point is an exponent of a 4. Do you agree?
Okay.
Okay, so I see this exponent, it's a 12. So how many rotations of 4, right? So I'm picking on 4, that I'm going to divide 4 into 12.
3.
So I know to go around 3 times, right? This is where I to the 12th is going to be. So I to the 12th is still going to equal 1 because 4 goes into it evenly, right? Does that make sense?
I guess.
Okay, so every time I'm going all the way around equals 1.
I need to go.
All right. Now 4, let's see how many times 4 goes into 7. We know 4 doesn't go into 7 evenly. So we're going to say just 1, right? Because 4 times 2 is 8. So I know I'm going to have how many left over? 3, right? So I went all the way around, right? But I've got 3 left. So 1, 2, I know it's going to equal negative I. So however many times, you're kind of like erasing, this right here. Like this is telling you what you get back, and then you look at your remainder. Anybody else want? Okay.
So basically, you go around however many times.
Well, you don't have to. Like, you're going to be there.
Yeah.
Yeah.
I'm
But then you're
saying,
more so looking at the remainder on, okay, well, third one.
Yeah.
Yeah. That's all you're doing. So 49. So 4 goes into 49. How many times? Well, 4 goes into 4.
11 times.
So that would be,
10 times.
and then that's 2, because that gives me an 8, right? And I just have 1 left. So I know I'm going to end up here on the 12th time, right? And I only have 1 remainder of 1, so I know it's going to be just an I. Just an I. So I know it's going to be a positive I. Okay. What about 99? Was it 99?
Yeah.
Yep, always divided by 4. Because that gives us right back to equals 1. So 4 goes into 9. We're going to say twice, right? And then 19. Was that 4? So for 16? And then I got 3 left.
And then 3 left.
So I know when I get to my 3, I'm negative I. Because I'm going to go, I don't have to go around 24 times. I know I'm going to end up at the positive 1, but I've got to go, that's only getting me to what? I to the 96. So I've got to go 1, 2, and then that gives me 2. Negative I. Get some tea.
So 5 is, correct me if I'm wrong, but 5 is negative 1?
Uh-huh.
Okay, cool.
Yep.
Nice, alright.
Because you're really just looking at the remainders. Now, some teachers will put like decimals to these, and so whenever you get, you notice we're either going to get, because this is in fourths, right? You got a quarter, you got 25, you got 75, and you got your dollar. So whenever you do that, you're going to get the same percentages every time.
Yeah, I
Yeah.
saw that because I do.
Yeah, the same every time.
Yeah.
So,
Cool.
yep.
Yeah.
So for
then the
54,
last
does 4
one-
go into 54?
Not
Evenly?
but it's-
So 4 goes into 5, and then that gives me a 1. So then when I bring down 14, 3 for 12,
yeah.
and then I have 2 left. So so 13 times around, I'm still here. So then 1, 2, I get -1.
And then number 6, 4 does go even.
4 does go into that. What, 18 times?
Yeah. 18.
Yeah, if 4 goes into it evenly, then you know you're going to end up with that positive
Yeah.
1.
Okay. It's not terrible.
So that's 18. So yeah, so just positive 1.
I saw the thing about powers and I was freaking out. But this is actually kind of easy. So that's good.
So you can kind of think about it, especially like if you wanted to use your calculator, you can see that, this is having 1 left over, right? So that's a remainder of 1. So that fraction would be 1/4. Your calculator would probably spit out the decimal form of that, which is a quarter, right? So 0.25. So that's why teachers assign, whenever you get whatever decimal piece, if you get 0.25, then you know it's going to equal I, which is what that one equals. So then if I have 2 left over, like this one, well, that's a half, right? That's 50 cents, so that's 0.5. So this one is going to be your 0.5, and we know that if I get a decimal of a 0.5, it's going to be a -1.
Yeah. And then like number 4 would be 0.75.
Okay? And then you have the 3, so this is 3/4, well, that's 3/4, so that's 0.75. And then that's your $1, your 1.
Yeah, so basically like the power is how many quarters you have.
So if that kind of helps.
That's neat.
Jackson, are you good? Okay. Looks like deer in headlights. All right.